To print a really large component on a really tiny 3D printer, there are a few tricks that you can do, and in this video I'm going to teach you my method and some do's and don'ts about it so you make sure your components are perfectly fitting into each other and it works every time. So let's go. Okay, so this is my project and I'm going to teach you that through this example. Assume this is a wall lamp and I will tell you why. This is a circular wall lamp with a diameter of 20 inches, about half a meter. And if I wanted to 3D print this, it would not fit to my platform because my 3D printer is small. And let me just insert it. It will look like this. It's a lot larger than my 3D printer and therefore I cannot print it like this. So what can I do? I need to segment this in a following manner that makes sense, and it's easy for you to assemble it, not just segment it in any way you want, because we want to follow some rules. Eventually our segmentation will look like this, but in order to get here we need to follow some do's and don'ts, and I'm going to teach you that. So let's just quickly do that. I'm going to start it from the top and draw a sketch. By the way, everything I do I use mouse gesture for faster speed, like this. I'm activating line, draw 1, 2, and draw a center line vertically up. Now I'm going to select this point and this line, holding the control key so I can multi-select, then I can click on make symmetric. Now they are symmetrical like this. Remember, the distance is not important. If I say, oh, I want this to be 100 millimeters because it would fit, then I'm dealing with a random angle of 18.47 degrees, which I don't want. Instead of a distance, I need an angle, which is something round that I can create a full circle from by repeating it a round number of times, like 30 degrees times 12, that would give me 360. So I'm gonna leave my sketch here. I don't even need to rebuild it. I would go to features and use the split tool. And since you don't have the split tool in SolidWorks, in your menu on default, just press S like Sierra on your keyboard and type split. It shows up here, select it, doesn't matter. And using this sketch as my trim tool, click on cut part. Then we want to check consume cut bodies and click this bigger half, a lot more than a half, and get rid of it. And this is our segment. Now, if I wanted to 3D print this 12 times and use glue to connect them to each other, I could, but then it would not be stable because I would be relying 100% on the strength of my glue. And I don't want that. Instead, I want to create some interlocking mechanism. To draw that, we need to follow some rules. Let's just say I want to draw something with 3 teeth. So everything I draw, I want it to be aligned collinear towards the origin. I draw 3 center lines from the origin all the way up here, like that. And I want them to be a little bit closer. So I can define that using a value for the degree. Let's just say 2 degrees. I could just give them 2, 1 by 1, or I could define an equation and use equations so I can adjust them one time altogether. Now, if you don't know how the equations work, I can show you that quickly as a bonus tip inside this video. So let me just show that. You go to tools, you go to equations, tools, equations, and then you define a new global variable like C, and then you give it a value like 2. Okay, ignore the errors, by the way. Again, close. Okay, so this time double click on the sketch to edit it, and you can see these are not just 2 degrees, they are variable. So it means I can change all of them by changing my variable B. Here, my B is 2 degrees. Let's just make it 3 and see what happens here. They go larger, right? Or they go bigger. So 2 is okay. If you don't want to work with equations and deal with all these errors that I'm dealing, has nothing to do with equations, by the way, in this case, you can just ignore that and give it like 2 degrees or 1 degree. Doesn't matter. Now, I want my interlocking mechanism to have 3 teeth like that. Okay, so from here to this line, go down, to this line, go down, and go here. Now, I could just leave it like this and close this one and just say, okay, that's good enough. But I would like to have some control over it, some discipline, some symmetry. So I want to define the inner and outer bond of the outer teeth, drawing 2 circles and checking for construction. So this is the first circle for inner bound, and there's a second circle for the outer bond. I would just fully define these by setting a distance here. Let's just say 3 degrees. Sorry, 3 millimeters and 3 millimeters. Now they are fully defined. So it means I want this area between the 2 circles to be where my interlocking mechanism sits, and it doesn't exit that. So I'm going to drag all these points onto the circle like that and do it here, here, and drag it a little bit more. drag it onto the circle and close this bottom half. Now they are not perfectly symmetrical. How can I do that? I could just draw another circle to be exactly between these two. And how do I do that? By the way, uncheck for construction because we want a center line. How can I do that? I could use dimensions for sure, but I would like to use center line again. Draw a perpendicular line. You can use these previews. See, it's snappy. That SolidWorks provides me, and it shows me the perpendicular symbol here to draw one line connected to the second circle and do it again. Perpendicular. Like that to this one. Now I have two lines collinear and I want to select them both, only these two, and make them equal. And they push this mid circle to the center, and now it's fully defined and it's black. What's the use of that? The use is I can just draw another center line on top of this line, perpendicular to that, then select it, use Control key, and select this mid circle. Then have these two tangential. Now I can select this line, hold Control, second point, third point, and then make them symmetric. Done. I could repeat the same task. Center line, perpendicular, press escape, select it, hold Control, select the circle, let go, make tangential, click away for de-highlight, select the first point, hold Control, select this line, select this point, and make them symmetric. Do you want me to do that one more time? Sure, no problem. Select here, draw a perpendicular, press escape, select it, hold Control, select the line, make them tangential, press escape. Now select this line, hold Control, and select these 2 points and make them symmetric. Done. Now look at this. I can just move these two like that. And I can even select this two and make them go equal and just give one value for this one. Let's just say 10, and it should be fully defined. The fact that it's not is because this is not sitting on the circle. And now everything is fully defined. The next step is the extrusion, but we don't want to extrude this all the way up here and click OK. It looks okay, but it's a straight extrusion. If I do this, my components would just slip through each other, and that's not what I want, okay? I want them to interlock to each other and don't go through each other. So the way I do this, instead of just doing a straight extrusion, I would activate the draft angle and change it to 5. But doing that just creates some gap here. Look, if I do the draft angle, I'm creating a triangular gap here, so I cannot merge this new volume to the first solid body. Therefore, I have to uncheck merge result and click OK. Now, in order to close this gap, I want to do a trick. I want to use this tool here, move copy bodies, and then select this body, uncheck copy because I don't want to duplicate it yet, and rotate it, not translate it, rotate it around this point, the origin. So for like 0.5 of a degree around the z-axis. You can see the preview. The blue component is the current state, and you can see I can move it that way. I just want to do that for 0.5. Why? Because that way I have pushed this triangular gap into the component and it's now fully connected. Before I combine this new component to the first solid body and merge them into one solid body, I want to repeat the same task. Move copy body, select it, rotate it again around the origin. But this time I want to check copy because I want to duplicate it, this time for 30 degrees. And I will tell you why. Look, now I have duplicated this component. I want to use the combine tool twice. You don't have it here. So press S on the keyboard like Sierra, type combine, and it will show up. Select it. First, we want to add this one to this one and click OK. Now we have these two. Now let's do this one. Again, use combine, this time subtract. We want to select this main body and subtract this one from it. Now this is perfect. I want to make sure if they are fitting perfectly to each other. So let's just run a test, circular pattern before we go any further. Check bodies because it's a solid body. And then rotate it 12 times around this circular path. And then, yes, it looks good. But before we finish this off, I want to do some fine tuning, and let me just hide this. Round the outer edges with a slightly bigger value, let's just say 0.5. Only the outer edges, not this inner edges. This is an inner edge. The ones who are pointing out, like these. And then same on this side, the outer edges only. So I have 3 on each side. And I'm selecting it like this and I click OK. Then I'm going to go ahead and round the inner edges with a slightly smaller value. Let's just say 0.4. So I'm going to do that. So like this, and this. Let me see if I can pick. No, we cannot. Okay, so this, and then we have probably 3 more on each side on this end too, making a total of 12 for each set of fillet. So 1 more and done. Now, if I leave it like this, then I'm reducing the chance of having them stuck together when I'm actually 3D printing them. Look, fit perfectly. And if I zoom in, these small gaps are because of the 0.5 and 0.4 radius. And you can use this to make sure that tolerances are okay, or even assume the glue that you want to use to connect these two to each other is going to fill up that gap. Anyways, that's something I would do. And this is how it will look like. Now, let's just get rid of the pattern. Save this component for the 4th time because I keep forgetting to record my screen. So I saved it as STL. Now I'm going to go back to my 3D printer software and I keep recording and boom, it fits perfectly. I need 6 of these because I can pre-print 2 sets and that would give me 12. Why 12? Because each segment is 30 degrees and so 5 and 6 and okay, and I can get rid of it and I can just slice it. It would show me the G code and the duration and all that. So 3 hours and 38 minutes, I can go print it. But I recommend you to not do that at first. Just print 2 segments only to save time and raw material. If these 2 fit together, like these 2, then you can go ahead and print it. And look at the draft angle here, by the way. This is the draft angle on each side. So it means when I just press it against this one, it cannot go any further. It goes down, but it doesn't go up. Okay? That's how we do it. And it doesn't wobble or anything. That's so airtight. And I can even add the glue for PLA and it would be like a concrete. In fact, I have done that on a larger wall lamp on my wall, this one with a diameter of 1.5 meters, about 60 inches, and it looks so dope and I love it. And I have printed this large wall lamp from this tiny printer over here. All right. I would like to thank Perusa for providing me with this printer. It's amazing. It helped me a lot in a lot of my projects, and I even used it to 3D print this large wall lamp that you just saw, and it looks amazing. All right, thank you very much for watching. Don't forget to subscribe. If you like this video, you will love the video on the right, which teaches you how to use a 2D paper scanner. Yes, a paper scanner to bring a component into SolidWorks and design it really fast. The video on the left teaches you more on sheet metal in SolidWorks, which is amazingly on demand and increases your chances of getting hired.